Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about deorbit. So let's dive deep into it. So what exactly is the problem? Well, reality is that rockets are overpowered for small tasks, meaning, and it's also have to do with physics because physics loves big rocket. The bigger the rocket, the lower cost per tonnage you're gonna get. So flat out, we have huge rockets. Now that creates a serious problem. They give you the cheapest rate for small satellite to orbit, but you have to go where they are taking you. They are like a bus. They have their bus stop. You gotta go there, man. It does not carry you to your house. It's like, bro, this is the bus stop. The end. So that creates an issue. Now, you may be like, hey, what if I put propulsion module in my CubeSats? Now, it can be done, but you have to understand CubeSats are very low, like lightweight stuff inherently. So they do inherently cannot last very long unless you are deploying them on moon or something like that. Generally, they are deployed in low Earth orbit. They do not have too much lifetime, and it's by design. We design it in such a way that these things do not become a hassle for our future. They will self-decay very quickly, but consequence they decay very quickly. So if you spend the time from, okay, I'm in this orbit, I'm doing something that is allowing me to change my orientation or orbit, whatever have you, that's taking away from your active lifespan. So it's not just like, oh, I can just change the orbit or something like that. It's taking away time, valuable time. On top of that, CubeSats are tiny, meaning they're small. So what does that mean? That simply means any propulsion module you put into it, however small, it takes away space from your payload. Payload is the one that is giving you money. So making it smaller is unwise. For example, Dove satellites, they are very popular CubeSats. They are tiny satellites, like 3U satellites. They have a telescope inside. So if they made a propulsion module in the back of it, the telescope has to be made instead of 3U, maybe 1U. Not even 1U. I think 2U they will be able to do. So they have to put propulsion module in 1U. So you realized you fundamentally degraded the quality of your optics. Undesirable. In all scenarios, especially with small CubeSats, if you do any sort of propulsion, you are taking space away from payload, not a desirable option. So if you use small satellite launchers, basically electron rocket or things of this nature, they're awesome. They're going to take you exactly where you want to go, but they're expensive. So it inherently becomes two things that you have to balance out: cost and access. These puppies give you amazing access. These puppies give you cost savings. So it's like you want the cost of bus, you want the flexibility of a taxi. So how do you get married together? So that's the problem right now many companies are facing. Generally somebody would come up with a solution is space tug. Now space tug is like having a small bus inside a big ass bus. So this is a Falcon 9 bus. You have a tiny bus. That bus delivers your passengers exactly where they need to go, exactly in right orbit, even if it's a bit different compared to what the main daddy did. So all this puppy needs to do is deliver them in orbit. Just like after that, I got you, fam. So that's the idea, and we call it last mile solution in orbit. And they have what we primary function of those puppies are what we call satellite dispenser, to dump satellites where they need to dump it. That's step one. Step two, propulsion module for orbit maneuvering, because there's no point, it's just a dispenser, it's no active point. But if you have orbitable maneuverability, then you can be like, hey, oh, you want in this orbit, I'm gonna deliver you, wait your turn, okay, now that puppy is done, then I can even raise the orbit, and then you're like, okay, I'm gonna drop you there, then change the inclination. It's like, okay, I'm gonna dump you here. So it can allow them to hand deliver, quote unquote, every single satellite to exactly where it needs to go. And each of the payloads, basically the actual CubeSat, does not have to spend space for propulsion module or the limited lifespan. So it's a win-win scenario. And they have to do multiple launches at the same time, because do not expect, it's like you're never gonna ride a bus for like one passenger. That's too stupid. So it's something similar applies here. So these puppy have to be full, only then it makes sense. And they have to have flexible storage, because even though I'm talking in use, these are units. 10, basically 10 centimeter by 10 centimeter by 10 centimeter is one unit. It does not mean everybody builds the satellite in that configuration, so to say. So some will have 3U is generally very common. Then you have something that requires a bit more oomph. You may have 6U, sometimes maybe even bigger than that, like freaking 4 units. So every brand, company, whatever have you, based on their requirement, they will design the system to their needs, so to say. So this has to be more like a container ship, where it's like, no, I can adjust things. Flexible storage is compulsory. Without it, it will simply not work. So let's understand this D-Orbit thing. It's a private aerospace company from Italy, which is a unique surprise. And what they are offering is what we call end-to-end service for small satellite, meaning you go to them and it's like, I want this. They're gonna design the satellite for you, build it for you, then they're gonna launch and deploy it for you in orbit transportation, because they're not only gonna negotiate with SpaceX, they're also gonna take care of after SpaceX dumped you into space, in orbit transportation and positioning, so you get exactly where you need to be, and orbital operation, meaning they're gonna handle ground operations for you also, and end of life disposal. Now this is the most critical aspect, end of life disposal. That's how this company started. The idea of this company was to take care of orbital debris. That's why the name is D-Orbit. Now they realized they were kind of early in the market, so to say. So they have offices in multiple places: Italy, obviously, UK, Portuguese, and USA. So they're around, and they started in 2011. So this is the time when they wanted to really look into taking care of basically orbital issues, deorbit in the name, but it was bit early. So they kept working on themselves, and they did first mission in 2013. Then they did first satellite in, if I'm not mistaken, 2018 or something like that. And then they had space tug. The final tug delivery was in 2020. So they have been doing things and rapidly, and they also provide solutions, software solutions for space industry. There are unique things that you and I do not need to deal with. Same way like an office individual has a need for Microsoft Office, there are other tool set, software tool set, that a company that is building satellites, dealing with ground service and all that jazz, they need certain software toolkit. Now those things are not as easily available as you might think. Kind of makes sense. So this company also takes care of those softer things. You may not think about them, but those are also important. So they are more of a service provider to companies, so to say, and tool for space debris deorbiting. That's their core goal. That's how they wanted to do. That's why the name, and that's how they will transition their company to. Right now, what everything they are doing is basically gaining experience, learning competency, and basically building foundation where they're going to have funding so they can take care of the space debris problem. And so far they have 10 orbital transportation mission, 32 hosts, and 73 satellites, and next launch is very soon when I'm recording this video. So quite successful given the age. So their biggest success story is Ion satellite carrier, this puppy, Space Tug. So you can say it's not very small, but also not very huge. Basically a big washing machine, I would say. And they did first launch on Vega rocket, that is from European Space Agency, on 3 September 2020. So this was the first time they did this puppy, and after that they used Falcon 9 Block 5 on 24 January 2021. So you can see they're moving, man. They're moving fast, and they are the only company as of now, as of me making this, they have fully ready, fully deployed system where it's just like take it and go. Other companies are also working on similar concepts, and many companies have the same idea, but nobody is like done like, yo, I've done it, already have multiple systems. So they are the only one that can truly claim, no, not only just I have also launched on 2 different systems from 2 different continents, one from Europe, one from basically America. So that's a very big advantage they have. So they have first mover advantage with headroom, meaning they're exactly like how SpaceX is right now. Like they have been doing what you call orbital class rocket relanding, and nobody has cracked it yet. Like nobody has a reusable rocket same way SpaceX has. And by the time other people may reach their first Mach 1 products with reusability, they will have like, bro, Starship is already complete. So this company is going into right direction, so to say, and their speed is damn fast. Then they focused on a niche and they just milked that puppy. So their future is directly dependent on fundings. Now funding they are getting from European Commission for business and all that jazz, and European Space Agency for space cleanup, so to say. So some serious pocket, and not to mention they are for basically privating funding, and they are actually delivering. So their businesses in terms of their finances is quite stable. Now, their core aim from day one was to tackle space debris problem, which the first products they really wanted to launch was this puppy. Basically, it's a small module for CubeSats, very tiny module. You put it on the back of it or front of it, depending on how you want it, and this will auto trigger once it's basically job is done. So once your satellite job is done, it will fire it, decelerate it, and cause a re-entry event. So that's how they started, and this was very good. Event, basically a teacher for them. You listen to their interviews, and flat out they are talking about like to make something that can stay in space and survive for months or even years. It's not easy. It's one thing to, okay, make something go to orbit and the end. It's something else to like go there, stay in orbit environments, withstand a high ionizing radiation for long duration, and then still be reliable after years. So they were tackling some serious thing. You may be like, oh, it's just a small box. No, no, no. Making sure that box works for 6 months in space, yeah, that's a very big issue. And yes, this is the system that they are using right now, and you can see there are different box configuration, because again, different providers may require different size, and they have propulsion modules, so they can directly deliver it where it needs to go. And this is also teaching them how to do that debris catching maneuvers. So they have these two are the founders, and they have a very clear goal, and they are going places. And at their current speed, I would not be surprised in next 5 years they actually start to do deorbiting also. So this was my presentation on deorbit. Hopefully you have liked it, learned from it. In that case, please click the like button, share it among your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.